In the Solar for STEM 200 case, we begin with the connectors and the cabling for the connection to the solar panels. There are two cables which are polarized, so you will always connect to the solar panels correctly. You will connect them to the cables which are supplied with the tripod and the solar panel assembly. We also have in its path a few test points to check the voltage and the current from the solar panels. A connector to access the solar panel output so we can load it down for experimentation, and a switch so we can disconnect it from the system. There is an LED which will tell us if it is connected to the system, so we're always informed regarding the connection during experimentation. We also have a battery case, and in this configuration, the battery is accessible. Beneath the battery cover, you will find a replaceable battery. When it finally loses its charge capabilities, you can replace it with another battery to continue with experimentation. You can also have backup batteries if you have difficulty charging the battery on a regular basis. For your convenience, you may merely buy a second battery and swap them out. In the path to the battery, we have a fuse which will blow, thus protecting the battery itself. We have a switch to disconnect the battery from the system and an LED to indicate whether it is properly connected to the rest of the system. Again, we have a connector which allows us to have access to the battery individually for experimentation. In either case, we have a load bank of resistors and a cable which allows us to connect the load bank to a power source. As we do this, you can see that the LED lights up to indicate that the load bank has power, and you can hear the fan, which is providing cooling air, preventing from overheating of the load resistors. Be sure the toggle switches are in the down position so all of the loads are not connected before connecting the load bank to the load. We can move the switches to the up position and add them incrementally, which enables us to measure the voltage and the current of the battery under load conditions as an experiment. This load bank can be connected to the solar output, the battery output, and the controller output for experiments. The controller controls the current going to the battery for charging. It also provides the output from the battery through it to DC loads. It takes in the solar panels to provide the charging current and voltage for the battery and the power to the DC loads. The controller has a 10 amp fuse and connector to access the output of the controller, a switch so that it can be disconnected from the inverter, and a light indicating it is connected or not connected to the inverter. The inverter is 120 watt, its output is AC, and we have two AC outlets. We have an indicator which tells you there is power on those outlets and a fuse just in case you have an issue and short the inverter inadvertently. Access to the output of the inverter is through test points 2 for voltage and the same common connection for the current, so you can measure the voltage and the current being provided to AC loads. When you experiment, you will be measuring solar output, voltage and current, battery output, voltage and current, the DC loads voltage and current, which includes the inverter, which has a load, and the output of the inverter for voltage and current. Now, if you multiply